Then let me welcome you to the discussion on artificial intelligence, especially embedded artificial intelligence. My name is Axel Sikora, and I do welcome warmly the three panelists. This is Michael Beigel from KIT, which is Jim Tang from MathWorks, and Nikolaus Forgo from Vienna. I'm really sorry for the delay in starting. We wanted to have an online poll with you, but it didn't work, so it took us a couple of minutes, so please excuse. We will do it in traditional way, asking questions, giving answers, as we normally did for the last 2,000 years. As you might have seen, the subtitle of the event, both of the exhibition and of the conference, is called Embedded Intelligence. And if you remember, there was a predecessor of Embedded World back in the 90s, which then, over embedded systems, moved into Embedded World. And this was the name Embedded Intelligence back in the 90s. So for this year, we decided that it might be a good idea to take this slogan again, having talked about them, the topic in the 90s, and now asking the question, well, is it real? And I would like to discuss this question with the three panelists. They are in alphabetical order. Michael Beigel. He is professor for pervasive computing systems and head of the TECO, the Telecooperation Office Research Group at Karlsruhe Institute of Technology since 2010. Previously, he was professor of distributed and ubiquitous systems at the Technical University of Brunswick and also guest professor at Keio University in Japan. In Karlsruhe, he's doing a lot of different activities, including Smart Data Solution Center, Smart Data Innovation Lab, and many, many more. And one of the nice colleagues in our neighborhood. Then we have, in alphabetical order, it's Nikolaus Forgo. He is also professor, but for IT and IP law and technology at the University of Vienna. In '98, he established and since then led the postgraduate program for information and media law at Vienna University. And since 2017, he has been a member of the Digital Council of Lower Saxony, and since October 2017, professor for IT and IP law at Vienna. So he will be our legal advisor in this discussion. And then finally, we have Jim Tang. You might have seen his keynote speech that we just had in the conference area. Jim Tang is a MathWorks fellow. And also when announcing Jim for the keynote, I already mentioned that translation or explanation of what a fellow is a little bit tricky. We gave several definitions, starting from, well, being long in the company, being member of the management board on the VP level, and having enough freedom for strategic thinking. Okay, yeah, that's the three panelists. And maybe we should start with the definition. We already had the chat before. What are we talking about? What is artificial intelligence? Answer should not take 2 hours, but okay. 30 minutes.
I will give it a try. Yeah, artificial intelligence is actually methods, algorithms, and tools that we subsumize under that term. And nothing more. It has the intelligence inside, which is somehow misleading, because it looks like we have an adaptivity, a creativity like humans do, which we don't have, at least not yet. So I see it more as a real tool set, which can be used for making systems better, cheaper, or making them more robust or more efficient. And that's it.
Not more.
Not more.
Maybe one piece more, which is I think that it is definitely a set of tools. I think that they take their cue from the environment and from the situations and have some ability to work both from rules and also to adapt and define new rules based on the scenarios that they have to operate in.
Mm-hmm.
For a lawyer, it's just a miraculous black box replacing human decision-taking by machines.
Okay, nice. What is specific about embedded intelligence? Is there any difference, or is it just running on different MCUs?
I think one aspect of embedded intelligence is, almost by definition of embedded, it has to work on constrained devices. And there's an assumption that they are changing and adapting without a person supervising them as they do that, which gets back to his point about black boxes.
Mm-hmm. Michael, I think you don't agree with the restricted devices, if I know you correctly.
Well, if you use embedded as in the core sense of having an offline embedded system, right? Which you you have that sometimes, if you want it, or even if you don't have network access, as you had it here. And then, of course, there is some constraints on the reliability. There's, of course, constraints also on real-timeness. Yeah, that's the second thing. So, of course, we have faster and faster computer systems now have GPUs which are inside embedded systems, but yeah, it comes at the price. Yeah, power consumption, etc. And in some cases, you cannot pay that price, and then you have a constrained system.
Mm-hmm.
For a lawyer, again, if there are reliability issues, there are liability issues, so it's even more fun then, right?
Another aspect of embedded is that in some cases, the way in which the rules are expressed are in a resource-constrained device. But AI, if you heard my talk earlier, AI somehow needs access to other processing to be able to be whatever you want to call artificially intelligent. So that connectivity is important for the adaptability, even if the way it's expressed is in a resource-constrained device.
Yeah, I just want to add, of course, what appears to be a miraculous intelligent system, yeah, is often a combination of many AI systems, actually. And therefore, of course, connectivity is a requirement for that. Yeah, you see this with all the cloud-based AI systems, which appears quite powerful, but these are not single AI systems, but combined AI systems.
So I will not play the role of the lawyer, but I think that's an interesting observation, because then you get to the question of what's the responsibility of composed systems of AI.
Mm-hmm. Absolutely. As different from day-to-day experiences in many other areas, this is a very complex system having several stakeholders, each of them being potentially legally liable, which makes a lot of fun for all kinds of legal claims, obviously. Yeah.
Mm-hmm. Yeah. Basically, I wanted to touch this issue about liability and reliability later, but once you have started it, maybe you should a little bit dig into that. Because, I mean, it's not only talking about complex systems, but maybe also about systems that we don't understand anymore. Does this change the overall role of liability?
Well, actually not at the moment. That's the good news. The bad news is that politicians all over in Europe have identified this as a major target, and there is a lot of debate ongoing on a European level, but also on a national level, in how far that should be regulated using new approaches and regulated in a way that is also to be compliant with ethical requirements, right? So there are ethicists, lawyers, legal philosophers, politicians, etc., all of them having arguments on this, which does not necessarily help Europe in having one common standpoint on this.
Mm-hmm. What would be your proposal? How would you draw the line?
Keep cool and try to understand what those people are doing in the black box, right?
So I just want to repeat on this question. So the question is, what is the difference to the way of traditional programming, where you basically have somebody who is an expert in the system, and then he writes a program, then he retries, and nobody knows exactly what is going on. What is the difference to the black box that somebody has programmed versus the black box that a machine has learned?
Well, I think maybe a little bit of a comment on Europe. Fortunately or unfortunately, the States has joined into that initiative. You know, the government has said AI is important, and I don't know what that actually implies because we have not started those arguments and discussions yet. I think it's an interesting question with programming because there's I'll say an original intent of the programmer, but if the behavior of the artificially intelligent system is dictated by data, then how do you determine that intent?
And I think from a legal standpoint, I mean, when it comes to torts, the traditional starting point would be whether there's any kind of negligence, right? The negligence requires that somebody has not properly written the code that then finally ended up in some kind of system crash. And that's much more difficult when there is this system taking the decisions on its own, making it much more questionable whether there is anybody to be blamed. And if there is nobody to be blamed, then the next question is, should there be some kind of security in those cases? So insurances taking over this task. Should there be any kind of ethical limits to these decisions that are taken that may not be taken under any circumstances, and so on?
I think the issue of negligence is an interesting one because I think in engineering, the idea of responsibility and negligence, I think, is more clear. I think in a lot of the data-driven areas, statistics being a good example, the path toward avoiding negligence is by saying, here's the data upon which I based my information. So it's a question of the provenance of the data and the governance of the data, not necessarily the origin of the tool.
I think it is clear, of course, that you need to identify what are the properties so that you have this liability that somebody else. But probably some AI systems are even make it even easier because systems tend to be more and more complex. If you can now replace a very complex software system with an RNN where you don't understand exactly what's going on, but you have these borders, and it might be even easier in liability terms to identify the points where you have to ensure the liability than before.
But do you think, or would you promise that an AI system works 100% reliable in terms of functional safety? I mean, during your keynote, we had the question, what about autonomous driving using AI elements? And then going for an ISO 26262 certification. I mean, on one side, we are working with statistics, and on the other side, we should have 100%, which is some kind of mismatch.
If you only do classification, like you just sort of implied a little bit, then it could be done with certain systems. If I do decision trees, it is easy to screen them and then to judge on the values that have been selected by the data training. So the answer is it depends on the AI system you're using. Mm-hmm.
I think that I'm not a lawyer, so I'll say something that's probably completely incorrect. But it seems like there's a difference between liability and responsibility. And I'll say social responsibility. So the question, I think, from a liability standpoint is, if an engineer builds a system, how responsible are they to create, I'll say, engineered guardrails? Mm-hmm. So the system, even if it's taught to do certain something, it actually doesn't do it because the engineer says, I will not let that type of malbehavior happen. Is that something that's actually expected, or is that the exception? Because all of a sudden that creates all sorts of other issues of liability, because do they anticipate all the corner cases where something could happen, and do I want to go there?
So actually, autonomous driving is a very good example for my point, because about 2 years ago, the German legislator went through a whole reform of all the laws on traffic safety and traffic roads. Straßenverkehrsgesetz is the German name. And the impetus of this was to make the German legal system ready to autonomous driving. That was what every politician said. Okay, we need this in order to allow German car manufacturers that are in a very strong competition with non-European competitors, not necessarily coming from the car industry. So we need these laws in order to make them more competitive. And the outcome of this now is that according to the situation as it stands at the moment in Germany, it's still the driver who still has the responsibility and or the final liability, even if he or she decides to use a kind of autonomous system, even if he or she did not recognize that it was not working, just in the case that he or she should have recognized this and was negligent in the moment when he or she did not intervene into the system. And the outcome of this is, of course, that it's a clear risk for every driver in Europe, and in particular in Germany now, to hand over to the system in situations like this. And this is not necessarily helpful for the industry. So the outcome is really a paradoxon, because the impetus was very, very industry-friendly and positive, and the outcome is a serious threat for the development and the market credibility of these systems.
But I mean, in a car, you still have a driver. I mean, there are lots of other autonomous systems around where you don't have a driver,
actually,
but where the system works autonomously.
I mean, there are 5 stages of autonomous driving, as you said. I mean, legally speaking, there are 5, right? And level 5 means no driver. And level 4 means there is a driver, but the driver never takes over because the system is able to understand even if it's not working and then working properly, right? So only in stages 0 to 3 you have a driver.
Okay, but then you can handle the liability as you described. I mean, if you don't have a driver, you cannot give the liability to a non-existing driver.
Stage 4 and stage 5 will require further legal changes. But even stage 3, which is probably very close to market readiness at the moment, is a serious risk for drivers at the moment.
So it's an interesting question. At what point, what are the actions that a person takes to become a passenger, not a driver? Right? I mean, because I'm still behind the steering wheel. I'm supposed to be paying attention to something, but I somehow have shifted responsibility to a thing. So, but am I a passenger at that point? I don't know.
At the moment, you're still a driver, which means that you are legally liable if the system doesn't do what it's expected to do. And you should have understood that it's doing this. I mean, a very, very famous example where you can discuss this quite intensely is this video that probably most of you saw from this Uber accident, right? So the driver in this accident, there was a driver, but she probably looked at her phone 2 seconds before the accident happened. And the legal question is now, was this negligent, right? So sitting there, looking at your phone for 2 seconds or even less than 2 seconds, sitting in an autonomous car. I mean, that's the very purpose of an autonomous car, that you can look into your phone in the meantime, right? And still, I mean, I wouldn't do this if I were this lady because of the legal risks coming out of this.
Maybe we can then touch also another question, because somehow we already had this. Which applications you would love to solve, or which problems you would love to solve with AI, and especially embedded AI, and which problems you would not like to touch? Oh.
Somehow this question gets a little too personal, it seems. Certainly recommender systems, things that will take a certain scenario and recommend things to me I like, because somehow that reduces the number of possibilities or brings up new possibilities that I might not have considered. And so things that are classifying and recommended and maybe even predicting can be interesting applications to me. Even things that recommend a way to optimize something that I'm already doing because I wouldn't see it otherwise. Controlling is an interesting one. That one is maybe there's a bright line somewhere there because of a lot of the things he mentioned earlier.
I mean, this is a question on with a sliding answer, because the more we understand how AI systems can be made more robust, and especially can be made more explainable, I think that is an important part of it. The more applications AI system can be used for. Yeah, if we can understand what is inside an RNN and CNN, and you know, we are researching on such methods. I mean, I guess all of us. Then, even for medical applications, yeah, for example, it would be a way to speed up development for such devices because this saves lives. Yeah, so why not doing that? Yeah, but from today, of course, when we cannot do that, we cannot use these methods. We have to use methods which are still explainable, but probably not that powerful, and then often the classical way to implement systems with a little bit of statistics is more helpful. Yeah.
Mm-hmm. Well, actually, I think 2 points to make. The first one is we have, at least in European law, a very old principle, which is that humans should not be subject to automated decision making. So it's even in GDPR, and it's clearly written there, a human may not be subject to anything which is decided only by a machine, which has, of course, a lot of legal and ethical implications. And the question is whether this is something that should be or needs to be changed. And the second question, quite related to the first one, would be, is it necessary, is it useful to build up some kind of regulatory sandboxes for specific areas of our society that are secured and that are following given and clear rules in which we pretend that all the other laws do not apply? I mean, all these liability and data protection and intellectual property laws that make it so difficult to develop things today, whether it would be appropriate to declare a given area as safe from all this, because the rules are clear, the risks are limited, and the approaches are so new that it's worth trying this. That would be the two priorities that I would see.
Yes, please. Do we have a microphone?
I can shout.
No, you should not.
With the self-driving cars, you gave some interesting information on the liability from a legal point of view, but what about user acceptance? So I can imagine that as a patient in a hospital, I would rather follow the advice of an algorithm which has been proven to be, on average, more accurate than a doctor who is overworked. So what do you think of, not from a liability legal point of view, but from a consumer acceptance point of view, artificial intelligence?
Next question.
Actually, that's a... Should I start? Okay, sorry. No.
Please start.
No, I was just going to make a comment about on average with what standard deviation. But I think that goes back to his point about explainability, because I think the explainability of these systems isn't just to technical people, engineers, statisticians, whatever. It is to the layperson, because it's the layperson who essentially has to subject themselves to whatever these systems do and have some idea of how these systems work in a manner that they are responsible in giving up whatever that right is to these systems.
Actually, I find that point very interesting because I completely share your point of view, but I think that that's very typical for this area here and this branch of people that are here. If you ask average people on the street whether they would expect in a hospital situation, the machine or the doctor to take the decision, I would expect that the majority would take the doctor. And I even know that the German Ärztetag, which is, you know, the professional organization of medical professionals in Germany, even decided explicitly on this last year, emphasizing that in any case it's important that the doctor needs to have the final decision, even if the machine has the better option to choose, right? So I think, I mean, the two of us have a rather similar point of view here, but I don't think that we are in the majority here. It could change.
I think it already changed, yeah. You see that consumer health is exploding. Yeah, people do quantified self, and this is the start of something. Yeah, what do you do if you have a medical problem? What's the first thing everybody is doing, no matter if it's in this audience or on the street? Yeah, the majority Googles. Yeah, and so the borders will shift. Yeah. And of course, there is some responsibility because there is Googling is not a good way to treat your medical problems. But of course, we need to be open towards good solutions, even if that means that we give away a part of the control in the terms that we don't do every step manually. Yeah, but of course the system has to explain the steps he's doing.
I think a big difference in the self-diagnosing piece with Google that I think the medical systems are evolving toward, which is important, is empirical. They're actually based on data as opposed to based on one interpretation of a web page description. And so empiricism is important in that regard, and I think everything that moves toward a data-based approach is just good.
But then in the end, I mean, the world will be changing, that's clear, or is changing. Will the machines take over? I mean, we are increasing dependency, don't we?
No. Very simple. AI is good for framed problems. This is why we need an ensemble of AI normally to address complex problems. And then, of course, the interdependency between both is again engineered. So AI is quite limited. Yeah, much more than people today think. So I don't see there is any takeover. Yeah. The takeover has been is ongoing on a different level. Yeah, you cannot do your tax income declaration without having a computer program, and the reason is not that AI has taken over. The reason is just that humans nowadays tend to make things so complex, and that means politicians, that you need machines to do it. And this is a principal problem we should address, really. But this has nothing to do with underlying technology. Yeah. And so we look at the wrong direction these days, I think.
Actually, my answer would be yes, but where is the problem? Because I mean, many of the decisions we are taking today on a daily basis are already made, or at least supported and often made by machines, and that's the very purpose of a recommendation system. And if you came here using Google Maps, many of us probably did. I mean, the system took a lot of decisions that 20 years ago I would have needed to take on my own, but I don't think that I was. I mean, that's a legal problem to me, that some machine takes the decision how to get here, because otherwise I would be lost and I would not be here. So I've got a lot of freedom out of this, and I don't think that it's I think the possibilities are at least equally important as the problems, and it would be useful if we in Europe started to talk about the possibilities and how to make them easier achievable using legal instruments instead of the problems.
Yeah, maybe this leads also to the next block of questions. What can we do nowadays with AI? What is the status of this buzzword? I think you have to answer this question, Jim.
A lot. I mean, I think that AI, as he said, AI is in many of the systems that we interact with today, but they're not called AI. They recommend things. They allow us to avoid doing things that we don't want to do. So, I mean, a lot of the quality of life that we enjoy is because of AI, regardless of whether or not we call it that. So, I mean, that's a cop-out answer in a way, because we could look at every step of things we do on a daily basis and say, is there somehow AI buried inside of that? And I think we'd be stunned how often that's the case. Stunned.
Mm-hmm. What is still missing? I mean, if you say we can do a lot, you didn't answer, you can do everything.
Well, I didn't say I wanted to do everything. I mean, there's an interesting puzzle here, because I think, as you were saying, AI technology is moving at a rapid pace in terms of people's understanding of it, predictability of it, and so on. The thing that's actually lagging, which I think has also been said, is the legal framework. And so it's an interesting question about when there's such a change, a difference in pace between the technology and the legal framework to rule on the technology. How's that going to work, right? Because things will be out of phase so often. And we don't expect the law to move fast. We don't want it to move fast in some way, but you also want to have it keep pace with the technology. So I think, to me, the things that we don't want AI to do is to put people exposed in places where it's legally ambiguous. That's what I would say is the case.
And then the lawyer says, keep cool.
Well, actually, I mean, that's of course a rather extreme position for a lawyer, but the other extreme is the one that we have seen in Europe for the last 20 years, and it was clearly not successful. I mean, the whole history of internet regulation and IT regulation since 1960 or so has been a constant failure, because law was always late, it was always too specific, it always regulated technologies that were no longer in the market, and the texts got longer and longer and longer and more detailed and more detailed and more detailed, and more lawyers debating on this without any impact on everybody's life. I mean, who of you really lives different due to GDPR today than a year ago? And how much money was spent on GDPR compliance in Europe? I mean, it's absurd in a way, right? So it doesn't have any impact, or it does have some impact. I don't want to be too extreme, but it doesn't have any significant impact. But it really brings a lot of additional complexity into the whole industry without any payoff.
I won't ask a question how to change
yes, I know. Situation. Please ask it. So the answer is less detailed rules, right? Mm-hmm. More of abstract, easily understandable rules. More of understanding what's going on the technology side by lawyers. More of trust into the legal system as it is understood by independent courts. And finally, interdisciplinary research undertaken by lawyers and IT specialists together.
Sounds like a long list of preconditions.
Or a very simple set of rules, one or the other. There's a fundamental issue, which is that with some notable exceptions, lawyers and politicians are not technocrats. And so I think the ability to determine when a policy is even viable technically, most people who are the policymakers are not in a position to even make that judgment.
Mm-hmm. Would you like to comment, Michael? No. I would like to come back to you, Jim, because when I asked what is missing, you said legal framework. That means technology-wise, we have everything that we need. No more development?
No, I think there's always more development, there's always more research. And certainly one of the things that I mentioned in my talk earlier today, which he also alluded to, is a framework for explainability. A technically rigorous way of describing when a system will and will not do what it's supposed to do. And I think that's both technical and it's also social. And then the follow-up, I think, is that we need a much more rigorous set of practices and techniques and algorithms for how to test and verify systems. Regardless of how you define test and verify as words, we just need more ways of really testing and verifying these types of AI systems.
And I want to add here, in general, understandability is the key problem in many aspects. The user interface, both to the experts, but also to the end users, both, yeah, is inferior as it is today. And understandability also for using AI, because there's a lot of hope connected to AI. Yeah, of course we know a few areas where it's working, but nowadays everybody tries everything to solve with today's AI technology, which is not economically feasible. Yeah, so we see certain AI projects failing, and of course these numbers will rise. Yeah, and then in the Gartner cycle, you are going down then, and this is foreseeable because the understanding where is the use, in what situations to use AI is not widespread.
I guess I'll also go back to a comment at the beginning, which is that AI is a set of tools. And I think I would probably differ a little bit, so we've been too kind to each other. I think understandability is a piece of it, but I think the real value of a well-designed AI system is if I'm interacting with it and I don't know it's AI. If the user interface is written so well that, in fact, it's doing things, and to me it's just a natural interaction with a system, then it's a well-designed system that happens to include AI in somewhere in its core and functionality.
But maybe another question to you when we are talking about, is it real? How many of your customers go for serious AI projects? I mean, of course, due to the hype, many will play around with it. But can you give us a percentage or a gut feeling of how many serious projects are really out?
I'm trying to remember what the original definition of AI in this session was. In some form where I'm using data to either create models for decision making or to optimize a process or to build some level of autonomous functionality, whatever that entails, the vast majority are doing it in some systems. Now, they're not doing it across all systems. I think the engineering equivalent of a recommendation system. That's very common now, and I think that's going to become more and more common. But as you look at more safety-critical systems, then clearly that's been the discussion we've had earlier, where that's moving slowly and appropriately slowly in some cases.
What would be your preconditions to use AI and when not to use? I think you made such a general comment.
Yeah, I mean. I already said that you need a clearly framed problem to use AI at all.
Can you shortly say what is the frame problem for you?
You need a clear definition. What is the border? What a system should detect or predict or adapt to? Yeah. Otherwise, you cannot train the system to do exactly that. Yeah. And then, of course, you need the data for that, easily accessible if you want to do it data-driven, which most of the time you are doing, because that can make the software development much more cheaper than it was before. And of course, the data must be accessible, cheap enough to pay off. Otherwise, you just do it the classical way. And if you can't do that, then do it the classical way.
You wanted to make a comment?
Actually, just one, which is if you tell me that you need the data, the answer would be we have a problem in Europe with access to data for many, many reasons, many of them legal reasons. And that's a serious problem because it's a clear disadvantage for European industry compared to other areas of the world. But I would also, if I may ask a question, which is if it's proper system design that the user no longer is able to tell whether it's a machine or a human speaking to him, is there, in your view, a legal or an ethical requirement that the user is told about this? Is there a need that should be transparent?
I don't know. I don't know. I mean, I'm always in favor of the full disclosure aspect. And when I'm using a service, I want to know the characteristics. But as you go into the detail of every interaction with the system, do I want to be reminded at every point that this happened, that happened, this happened, that happened in an automated way or in a engineered way? That's a level of detail I don't want to know. So I don't know where the threshold is on that.
Probably I may add one aspect. I think it's important that you know who is basically interfacing with you, because if you build up user interfaces, this is not a one-way process. It's a two-way process, and so people will adapt talking in their natural way to systems, but they can only do that. And they do it like indirect. They can only do that good if they know if on the opposite side there is a machine or a human, and then they will adapt differently, yeah, which improves the usability. Just for that simple reason, it is required that you know.
From the applications that you are seeing, is there any hot area of applications where your customers go for intelligent solutions, or is this covering all disciplines, all application fields?
It's a pretty wide spectrum of applications that we see. I mean, we see them for people who are designing systems that have more and more autonomous functionality, however you want to describe that, where it can do things on its own without a user directing it to do that task. And then a lot of things that are the equivalent of recommendation systems, optimizing something or recommending a way to optimize something. You just see that left and right in terms of the applications. And the interesting thing is that it spans every industry that we interact with. So it's not just the automotive or the aerospace industries. It's in mining and industrial automation. Types of applications that are, well, especially mining is more low tech, if you will, but we certainly see it arising there as well. So I think it's a very broad spectrum of areas.
Okay, time is running, so maybe it would be a good opportunity to ask you if you have additional questions to the panelists. Can you maybe come to the front and use the microphone?
So thank you for the very interesting talk. When we talk to companies, there is some, in my opinion, missing, you haven't discussed yet. What are the main hinders? And if we talk about the war for talent, especially here in Europe, and I can read more and more that also, it's the market for next generation IT expert, data scientists, and even engineers. Even in the US, the market is ripped out. You are hiring, or the companies are hiring directly out of the universities the people. So what can we do there? Do we have to work till we are 80? Well, most of you will like it, me too, but how we can solve that problem? Is it more about even more intercooperation, collaboration?
I think a lot of we observe is that it's a matter of expanding the literacy of the people who are in those jobs. From our viewpoint, it's taking engineers and making them more familiar and comfortable and capable of using analytical methods with data, respecting data as much as scientists do in some ways, and of not just holding so close to their heart the first principles of physics, right? Because I think there needs to be more, and that's not only just make it a more well-rounded technical person, it's also to enable the person to have a reasonable conversation with their colleague these days, because their colleague may have a completely different background. And so it's really an upskilling of skills and literacy in these areas, in my view.
What does academia say?
Yeah. I mean, we are extending, of course, all the courses that have to do with AI in a rapid pace. We also extend, in general, the number of students that we take. But of course, this will not be enough because it's not fast enough. Yeah, we cannot wait for another 6 years. Well, we can say we just wait for the next financial crisis and then things will sort out. But what we are doing is we have various programs. Axel just mentioned them at the beginning, SSC, etc. And connected to that are workshop courses, tutorial courses for people in already in jobs. This is what we are doing here in Germany these days. We hope it will be enough. And the second thing, of course, is we need to increase the usability. So the accessibility also for the engineer that has been educated in mechanical engineering 20 years ago has to be able to use these tools as well.
And I also think from a tool, I mean, we're a tool builder. And so I think our responsibility as a tool builder is to make the tools such that anyone can do it. Knowledgeably, responsibly, but that they can do it. It's accessible. And
that's
so
not possible yet with your tools nowadays.
Well, I think, ouch. I think it's two things. It's a matter of tool design. It's also a matter of accessibility to the tools that people actually understand it's doable. Not that the tools permit it or don't permit it, but that's a wish-washing answer. I mean, I think Gartner has the concept of citizen data scientist, that anybody can do citizen, as a citizen can do data science. And in the last reports, they talk about citizen engineers, which I looked at and said that's kind of a weird comment. But citizen engineers to them are engineers who can do data science. And so that to me, it's that kind of broadening of the skill set.
Any possibilities to educate the lawyers and speed them up?
I mean, probably not really. I mean, I think I already said the most important point in my view would be change the mindset. Right? We have a mindset problem in Europe because we are very good in identifying problems and debating on problems, but we are not that good in finding solutions, and that is the priority at the moment. And the second point would be educate the educators, because when you are not in an IT department at a university, the typical mindset of the educators is can be ignored, will not be relevant before I go to retirement, don't want to change, right? And as long as it's like this, it will not change, and so on.
Okay, so I'll be the optimist from a legal standpoint, which is that, as I understand law, so much of it is based on precedents. You start with precedents, you build on precedents, you describe when you're making an exception or change to precedents, and that seems to be perfect for AI.
Probably we didn't touch this issue yet. Robot could make mistake. Lately, I read an article on Chip Magazine, and it mentions that Amazon's robot recruiting robot make mistake. It has discrimination issue. It chose only men and black people as the candidate. So actually, the robot has made decision for us before we notice that it has made some decision for us. For this kind of issue, how could we avoid that? How could we, avoid that?
A more rigorous choice of training data. I mean, I think there was a bias in the people who did the design of assumptions of the data that was used to train the system, and those blinders led to the behavior that I think we observed. Now, I could go back and say from an engineering standpoint, there should have been requirements written that spanned that in terms of gender and in terms of ethnicity, but requirements themselves are almost more difficult to understand than AI.
I mean, that is a problem that you have in principle with data-driven AIs in general. If you have unbalanced data sets, yeah, and you often have them just for practical reasons, then you end up with mistakes, and then you can have these mistakes. There's a second source of discrimination that you may have, and of course the results of any training is rechecked by the data engineer, and he might implicitly, yeah, associate parameters that he sets while training with the result. Yeah, but this happens also if you do it in traditional programming. So, of course, you can do it perfectly, and then you don't have that problem. You double blind everything, and you have the perfect balanced data set. But in practice, this is very hard to do.
We have time for one more question, maybe, if you like. Then I would have one last question to all three of you. Basically, you already answered this question in your keynote, so it's an easy job for you. What will the AI life look like in 2030? You might also answer 2040 if you like. Maybe Jim has the advantage because I asked this question.
No, but I have to wait because other people will be biased by my response.
Oh, no. If you like, go ahead.
No, please.
I won't.
No, you have to.
I have to. Okay.
Yeah.
Actually, I don't know. I mean, if I knew it, I would buy shares, and I would not. I mean, I don't know. Let's see. But I think. I think we need to be very careful in Europe because we are in a critical situation at the moment, and things are not developing very well for several reasons. And I try to be optimistic for Europe, but I'm not always.
Mm-hmm.
Okay, indeed a difficult to answer question. You know, the visions that people had, what happens in 2020, which is 1 year ahead, 30 years ago were completely different than what we have today. Because the life today is very similar to the life that we had 30 years ago, except for that. And probably the things that we see through that device. And so, actually, I think the daily life will be quite similar. Yeah, but many things will be more automated, and a lot of burden, and of our daily manual things that are annoying, etc., or probably dangerous. I said medicine will be an area where we expect some progress. Will be just different, yeah. But other than that, we will sit here. Yeah, there will be chairs, yeah, and microphones. Yeah, very similar than what we see today.
No, it's your turn.
Yeah, we will be biologically very similar to what we are today, I hope. So I think it depends is an important answer. I think that what I said in my talk earlier is that it really depends on our ability to characterize when and how and why AI works. Because we need that vocabulary and that explainability to be able to communicate to lawyers and to politicians and to and to society at large. And I think that will gate the acceptance of AI into a lot of things. I think it'll grow a lot in terms of, I'll say, the recommendation systems, like, it could happen, it might happen. But for the systems that must behave in a certain way, I think progress will be quite slow. As I think it should be, because I think that's a conservative approach that makes sense until we develop that vocabulary.
Okay, great. Thanks to all three of you for your good ideas for the lively discussion. You made life very easy for me. Thanks for you to come along, that you took your time. There will be additional panels around the 3 days. And for now, we also would like to invite you to a short walk. Basically, we intended to call it AI Talk and AI Walk afterwards. Together with Bertolt Brackemeyer from Nürnberg Messe, there will be a tour to some of the companies around the exhibition which are working in the field of embedded artificial intelligence, and just to take a look at how far they are already real or virtual, what is available, what is not available. Thanks to all of you. Thanks to you.